How can you understand call stacks and versus code debugging? Imagine you're trying to solve a mystery in your code. The call stack is like a trail of clues showing you how your program got to where it is now. When you run your code in Visual Studio Code, the debugger helps you see this trail clearly. The call stack shows all the functions that have been called to reach the current point in your program. It lists the most recent function at the top and the earlier calls below it. This order helps you understand the flow of your program step by step. When you start debugging in Visual Studio Code, you usually set breakpoints at key lines of code. Once the program hits a breakpoint or an error, the debugger pauses execution. At this moment, you can open the debug view where the call stack appears. It displays a list of functions that led to the current line. The top entry is the function where the debugger is paused. The entries below show the functions that called it, going back in time. This helps you see the path your code took to reach that point. You can click on any function in the call stack to jump directly to its source code. This makes it easy to examine how each function works and what variables are involved. If you want to understand how a particular function was called, just double-click on it. The editor will take you right to that part of the code. This feature saves time and makes debugging more efficient. Right-clicking on a call stack entry gives you options like running to a specific function, setting breakpoints, or going directly to the source code. These tools help you control the flow of your debugging session. For example, you can run the program until it reaches a certain function in the stack, helping you isolate issues. When an exception occurs, the call stack becomes especially useful. It shows you the sequence of function calls that led to the error. This way, you can identify which part of your code caused the problem. If your program uses multiple threads, Visual Studio Code can display call stacks for each thread separately. This is helpful when debugging programs that run several tasks at once. Using the call stack along with other debugging tools like variable inspectors and watch windows gives you a complete picture of what's happening in your program. It helps you see not just where the error is, but how your code arrived there. Regularly checking the call stack during debugging makes it easier to understand complex code flows and find bugs faster. Mastering this tool in Visual Studio Code turns debugging from guesswork into a clear, logical process.